So students, we have seen in our previous episode few questions on continuity and differentiability. Now continuing on the same, we are going to discuss few more questions which are being asked in the CBSE exams. Now here is a question. If fx is equal to cos square x minus sin square x minus 1 upon root of x square plus 1 minus 1 when x is not equal to 0 and k when x is equal to 0. This function is continuous at x is equal to 0 and we have to find the value of k when this condition is satisfied. So students, first of all we have to see this function when x is not equal to 0. What can we do with the terms given over here? Let us try to simplify a little bit. When fx is not equal to 0, we can write this cos square x minus sin square x as cos 2x minus 1 upon root of x square plus 1 minus 1. Now since there is a square root in the question and we need to rationalize it, so we rationalize it by multiplying with x square plus 1 upon root of x square plus 1 plus 1. On simplifying it further, we get cos 2x minus 1. What is cos 2x minus 1? We know that cos 2x minus 1 is minus 2 sin square x multiplied with root of x square plus 1 and the denominator a minus b into a plus b will become a square minus b square. So that will be x square plus 1 minus 1. So this one gets cancelled. So this is a simplifying step before we take up the right hand limit or the left hand limit. Now we take up the right hand limit and apply that in this part of the function. Right hand limit at x equal to 0. Limit x tending to 0 positive fx, which can be written as limit h tending to 0 f 0 plus h. Now let us apply that in this given function. Limit h tending to 0 minus 2 sin square 0 plus h into root 0 plus h whole square plus 1 divided by 0 plus h whole square. See again what we have done. Minus 2 sin square 0 plus h multiplied with under root of 0 plus h whole square plus 1 to, if you want to put a bracket, you can put the bracket. Now simplify it and apply the limits. Simplifying it further, this gives us limit h tending to 0 minus 2 sin square h, inside the root it will be root of h square plus 1 upon h square. So this sin square h upon h square will become 1. This h will become 0. So we will be left with minus 2 into 1 plus 1, 2. So that is minus 4. Now as right hand limit is equal to f of 0, already given in the question the function is continuous, so we get minus 4 is equal to k. Hence the value of k is minus 4. See again from here, after substituting the value x as 0 plus h in throughout the function, this is simplified as minus 2 sine square h root h square plus 1 upon h square. So sine square h upon h square become 1. This becomes 0. So we are left with minus 2 into 2, that gives us minus 4. And as right hand limit is equal to f0 is equal to the left hand limit, but there is no need to take left hand limit as the function is already given continuous. So we get the value of k as minus 4. So students, you must have understood that how to do these kind of question. Let us take one more important question which you will be able to do. Now the question is, if fx is equal to sine a plus 1 x plus sine x whole divided by x when x is less than 0, c when x is equal to 0, and root of x plus bx square minus root x upon bx raised to the power 3 by 2 when x is greater than 0. Fx is sine a plus 1 x plus sine x upon x when x is less than 0, c when x is equal to 0, and root x plus bx square minus root x upon bx raised to the power 3 by 2 when x is greater than 0. This function is continuous at x is equal to 0, and hence find the value of a, b and c. This function is continuous at x is equal to 0, and we have to find the value of a, b and c. So students, left hand limit will be applied in this function. f0 is already given c, and the right hand limit will be applied in this function. So let us do one by one. First of all, f0, which is c, we leave it as equation number 1. Then left hand limit at x is equal to 0. So we get limit h tending to 0. We apply the values here. Sine a plus 1 0 minus h plus sine 0 minus h upon 0 minus h. 0 minus h will become minus h, 0 minus h will become minus h. Both the minus will come out because sine of minus theta is minus sine theta. So that sine, minus sine we can take out, and we are left with sine a plus 1h plus sine h upon minus h. So this minus gets cancelled. Now as we have studied the property, sine theta by theta is 1, so we can split this function into two parts. So this will become sine a plus 1h upon h, and this will become sine h upon h. Sine a plus 1h upon h and sine h upon h. Now students, you have to apply the property. Of course, this sine h upon h will become 1, but here the angle is a plus 1h. So I need to multiply and divide with a plus 1. So we multiply and divide with a plus 1. So this becomes 1. This part also becomes 1. So we will be left with a plus 1 which gives you a plus 2. So this is the value of the left hand limit. Now moving ahead, we have to also find out the value of the right hand limit at x equal to 0. So we apply the limit here, but before applying the limit, we will rationalize it to remove it so that it doesn't get 0 by 0 form. Limit h tending to 0, this will become 0 minus h, that will be minus h. In place of x we write 0 minus h, so that will become minus h, I hope you are able to see, plus b times 0 minus h, that becomes h square minus root minus h. Oh sorry, this will be plus because it is RHL. 0 plus h, 0 plus h. This will become b into h raised to the power 3 by 2. Now we rationalize it. H plus bh square plus root h, and this will be also h plus bh square plus root h. See again, 0 plus h, that is h. Here also 0 plus h whole square, which is h square. This is also 0 plus h, which is h. Now we rationalized. Simplifying it further, a minus b into a plus b will give you a square minus b square. So that gives you h plus bh square minus h upon bh raised to the power 3 by 2 multiplied with h plus bh square plus root h. So I can take root h common from here. Inside the bracket I will be left with root of 1 plus. So students, we have seen limit h tending to 0, h plus bh square minus h. So h and h gets cancelled, and this is bh raised to the power 3 by 2. From here we have taken out root h common, so we are left with root of 1 plus bh plus 1. Now simplifying it further, limit h tending to 0, this b and b will also get cancelled, and h 2 minus 3 by 2 upon root h, and this is 1 plus bh plus 1. So this 2 minus 3 by 2 becomes 4 minus 3, half. So this value and this root h will also get cancelled. We apply the limit over here, h tending to 0, and the result will be half. See again, h raised to the power 2 minus 3 by 2, taking the LCM it will become half, that is root h. This root h and this root h will get cancelled. We apply the limit over here, so we get 1 by 2. So students, we have got f0 as c, we have got the left hand limit as a plus 2 and the right hand limit as half. So c value is half because this value and the right hand limit are equal. Then second, a plus 2 is also half. So this gives us a is equal to, we check 2 on the other side, half minus 2. So that gives us minus 3 by 2. And b can take any value. B belongs to any real number. So b can take any value except 0. B cannot be 0. So students, we have seen that c value is half. C value is half. A value is minus 3 by 2 and b value is all real numbers and b is not equal to 0. We can also rewrite this as b belongs to r minus 0. This can also be written like this. So this is a long question, and this is the way you need to simplify the left hand limit, and this is the way you need to simplify the right hand limit. So keep solving and keep watching our channel, Ashish Singhal #maths, and we'll keep on uploading more solutions on continuity and differentiability. Thank you for being there. Goodbye.